Hello, and thank you for watching our video on voice and unified communications at a high level presented by RouteHub. Before we can talk about some of the protocols and features, let's talk about some of the main components that you will see in a voice and unified communications environment. The main components are call control or call processing, endpoints, voice gateway, and voice applications. The main component, the most critical component listed, is the call processing component. It is responsible for connecting the other components together. It is responsible for registration, call setup, call teardown, and providing a wide variety of voice features and capabilities for the environment. Some hardware examples are the Cisco Unified Communication Manager or Call Manager and the Cisco Call Manager Express. Endpoints or IP phones are devices that an end user will have with their associated phone number. Some hardware examples of that are the Cisco IP 7970 and the 7960 models, including the Cisco IP Communicator, which is the software version of the IP phone. The voice gateway connects directly into a PSTN or a phone provider for placing and receiving external calls. Some hardware examples are the Cisco ISR 1861, the 2800 series, the 3800 series, and the Cisco Unified Communications 520 model recommended for small and SMB businesses. Then you have voice applications, and the main applications that are used are voice and unified messaging, which provides voicemail capabilities including auto attendant. And some hardware examples are the Cisco Unity and Cisco Unity Express. Call center is used for help desk or for technical support centers that want to have call queues and various scripts for various call routing requirements. An example would be the Cisco Contact Center Express or the Enterprise version. And there's other kind of applications related to advanced conferencing utilizing Cisco Meeting Place Express and so forth. So these are the main components that you will see in a voice and unified communications environment. In terms of protocols, there are two main types of protocol based on their groups. There is voice control and voice data. Voice control is responsible for call registration, call setup, call teardown, and access to various features and capabilities available within the environment. For example, it could be Skinny or SCCP, which is a Cisco-based voice control protocol. So this is what the IP phones are using to connect to the call manager server and for placing and receiving phone calls. SIP and H.323 are the industry standard voice control protocols, where SIP is more widely used in today's industry. MGCP is a voice control protocol that is mainly used between a voice gateway and a call manager solution, a call processing component, to provide dynamic call routing throughout a PSTN. When a call is set up using one of the voice control protocols, the actual phone conversation occurs. This is the actual voice data, and the actual protocol is the RTP, and that consists of an RTP stream. So both of these are protocols that are seen in a voice network. Voice gateway. So a voice gateway can talk back to the call processing component via SIP, H.323, or MGCP. Again, it is recommended that MGCP is used for the call control protocol for dynamic call routing throughout the PSTN. A voice gateway could also have a wide variety of ports that could be analog or digital connecting to the PSTN. For analog, it could be an FXO or an FXS. The FXO is an analog line that connects directly into, like a phone jack, that connects directly into the phone provider. That phone line is associated with a DID or phone number. An FXS is used for connecting analog devices such as analog phones or fax machines. A digital line will be an IZN PRI, which can place and receive up to 23 calls at a given time per ISDN connection. And here's a diagram that puts all this that we talked about in terms of components, protocols, and aspects of the voice gateway into a single picture and showing even the traffic flow. Here we see two call processing components, one being a publisher, one is being a subscriber. They're both communicating via a protocol called SDL. We also see two IP phones communicating to the call manager servers via the SCCP protocol for either registration or for call setup or call teardown. Between the phones, we can see that if a call is placed, we have an RTP stream that occurs between them, or if it's an external call, it would happen between that phone and the voice gateway router. Between the voice gateway router and the call processing component, we see that a voice control protocol of H323 or MGCP is used for call routing. From the voice gateway router, we see that it's connecting into the PSTN using a PRI line, and its voice control protocol for call setup is Q.931. And you can see we can have other applications like voicemail or other SIP-related systems connecting directly into the network, connecting into the voice or the call processing component via SIP or other protocols. Access codes. So access codes are usually a 9 or an 8. It could be any number, but this is commonly used for external or inter-cluster calling. So for example, if I am internally within my company and I want to place a phone call from point A to point B, like outside my company, I would dial 9 first, then the full phone number. That's going to match a route pattern on the call manager system that would know how to route that to the appropriate voice gateway and PSTN network. SIP and Cisco. With generation 1 and 2 of the Cisco Call Manager product line, which is Call Manager 3 and 4, it had very limited SIP support. If you had an IP phone with the SIP firmware, it required you to have a SIP proxy server in place where your SIP phones connected to the proxy server, and there was a SIP trunk that connected to the call manager server. It provided a lot of complexity. Starting with generation 3 and higher, with Cisco Unified Communication Manager 5, 6, and 7, it provided full and integrated SIP support for SIP endpoints and for integration with like Microsoft Exchange 2007 for unified messaging. The one thing about voice and unified communications is providing quality of service, proper voice treatment for voice packets, voice control, and voice data to provide what we call end-to-end QoS. And these are the main components of providing quality of service for a network. That first we classify what data we want to look at, voice, data, video, etc. Then we mark what is the particular priority, high, medium, or low. Then we have an optional thing of policing, saying that voice will have this amount of traffic and data could have this amount of traffic. This is more of an optional thing. Queuing and scheduling have very different purposes and provides congestion management and congestion avoidance. Next we have traffic shaping, compression, and fragmentation, which are elements relevant to QoS across a wide area network. This concludes this video overview of discussing voice and unified communications at a high level. You can find out more information on configuring some of the voice components, voice gateways, call manager at routehub.com/training. Thank you for watching.